bisectors yesterday with perpendicular and angle bisectors. Those gave us the circumcenter and incenter. So now we have two other things in our triangles. We have medians and we have altitudes. And we're going to talk about what those make when they intersect. So first things first, let's talk about a median. Median is a segment. A median is a segment with endpoints being a vertex of the triangle and the midpoint of the opposite side. So I drew in a median here, this blue line. It's from the vertex, this vertex, to the opposite midpoint, which means it splits that segment right in half to the opposite midpoint, which makes those two segments congruent, the two red dashes. So if I connected the medians, if I drew in all the medians of a triangle right here, so I got the median, this blue median BF, this black one AE, and the green median CD. Well, they intersect at a point called the centroid. It's called the centroid. It's kind of like the exact center in a way. It's kind of like the exact center of a triangle. Okay, it always falls inside the triangle somewhere. Well, the cool part about it is exactly 2/3 of the distance from each vertex to the midpoint of the opposite side. So let's think about that. Let's look at my blue guy here. So it's saying from the vertex, right, from the vertex to the midpoint of the opposite side, it's 2/3 of the distance. This centroid is 2/3 of the distance all the way across. So from B to P, this is 2/3 of the entire distance. So let's think about that. If that's 2/3 of that, so really, now we'll look at the black line here. So AP, I'm saying AP is 2/3 of this entire line. So that's what I'm saying. AP is 2/3 of AE. So for example, let's say AP was a distance of 6. That means PE would have to be 3 because AE all the way across would be 9. And 2/3 of 9 is 6, which AP is. Okay, so there would just be an example of that. And that works for every single median. So with the blue one, right, BP is 2/3 of BF all the way across, and CP, right, from the vertice to the centroid, remember we're always looking from the vertice first to the centroid, is 2/3 of the whole thing. So that would be a median. A median, right? Medians go to the middle, the opposite middle, the midpoint. So median middles, and they make the centroid right in the center. So let's use that. It says P is the centroid, right here, P is the centroid. So that means it's made up of medians from vertice to opposite midpoint. Well, some things I know. I know that splits into sides, congruent sides, right, because midpoints. Well, YV, this entire segment, YV is 12. That whole thing is 12. Well, what do I know about YV? Right from vertice to the centroid is 2/3 of the whole thing. So if I took 2/3 of YV, I would get what YP is. If I take what 2/3 of YV is, I end up with what YP is going to be. So I know that YV is 12, so I just plug in 12 here. So I take 2/3 of 12 to find what that YP is. Well, I can put 12 over 1, cross cancel here. 3 goes into 12 4 times. Well, 2 times 4 is 8. So 2/3 of 12 is 8. I'm sure some of you could have done that mentally, but there we go. I figured out what YP is. Well, if that's 8, I know that PV has to be 4 because it has to add up to 12 overall, right? It's the other third of it. So I know that PV, it's a neat looking V there, is 4. So just use that information. Anytime you have a centroid or medians that intersect, you know that from vertice to the centroid is 2/3 of the whole distance. That's all there is to it. So let's use that centroid to help us find something. So for example, an artist is designing a sculpture that balances a triangle on top of a pole. So anytime you need balancing, you need the exact center of a triangle, hence the centroid. In the artist's design on the coordinate plane, the vertices are located at the following. I got them graphed. What are the coordinates of the point where the artist should place the pole under the triangle so that it will balance? So there I'm thinking I need the centroid. And where should they place it? So I need to find some coordinate that they need to place it at, right? Because I'm dealing with the coordinate plane. Well, to do this, I just need to deal with one of the medians. So I'm going to draw on one of my medians, right, from vertice to opposite midpoint. I'll deal with this guy right here because it gives me a horizontal line. Well, let's get my points into play. So what points am I dealing with? I'm dealing with this guy, which is at 1, 4 right here. And this guy, I mean, I could look, but to find it, it's just the midpoint of these two, 3, 0 and 3, 8. So to do that, I find the average of my x's and the average of my y's. Well, average of my x's, 3 plus 3 divided by 2 is still 3. And 8 plus 0 divided by 2, which is 4. So there's my midpoint. Well, how would I know where to place this guy? Well, what do I know? It's 2/3 the distance from vertice to the opposite midpoint. So 2/3 the distance. I know it's somewhere, I look at my triangle, somewhere in there, right? 2/3 from the vertice to the opposite midpoint. Well, how do I know what 2/3 of that distance is? Well, I might have to find the distance of that blue line, won't I? So I got to find the distance. Well, I can just count in this case, otherwise I have to use the distance formula. But here from 1 to 3 is a distance of 2. So I know that's 2 units. And my centroid is 2/3 of that, correct? So I can take 2/3 of 2. Which gives me 4/3. So is that my answer? No, I want to know the actual coordinate. Right? I want to know the actual coordinate up here. Well, what is that coordinate where that's at? It's 4/3. What's that distance 4/3? That's dealing with the distance from vertice to the centroid. So I got to add 4/3 in the x direction from this point. Well, if I add on 4/3, or that's really what, 1 1/3? So I'm really adding on 1 1/3 onto this point here, onto that x value, to get to my centroid. So my centroid has to be at 2 1/3 and 4 units up, which is right there. So that's kind of confusing. It takes a little bit of work. Okay, and I lucked out because I had a horizontal line. I didn't need to use the distance formula at all. But use that information about the centroid. So with the centroid, you only need to use one line. That's the nice part about it. With altitudes, we're still going from vertice, but instead of opposite midpoint, we're going to the opposite side perpendicular to the line. So if I look at this top vertice here, I went to the opposite side and made a perpendicular. And sometimes you have to go outside the triangle to find that. Hence my triangle over here. If I look at this vertice, the opposite side perpendicular falls outside that triangle. So my altitude, when they intersect, they can intersect inside or outside of the triangle. And I did that here. We call that the orthocenter. The orthocenter is where the altitudes intersect. So if you take a look, I drew an altitude for each vertice. So I went from this vertice to the opposite perpendicular, this vertice to the opposite perpendicular, and this vertice to the opposite perpendicular, and that gave me the orthocenter where they intersect. Boy, finding the orthocenter might be kind of tough, huh? I got a problem here, and I want to find the orthocenter of this triangle. Well, let's look back. If I'm going to find the coordinates of an orthocenter, think about this. I'm finding the intersection of lines, aren't I? Well, a couple chapters ago, how did we find the intersection of lines? We needed two equations in slope-intercept form that we could set equal to each other when we made our system of equations, didn't we? So as long as I know two lines, I can find the intersection of those two lines. So really, I don't need to find all three altitudes in this case. I only need two of them. So pick any two you want to use. Okay, so I'm just going to kind of draw in the two I want to use. I'm going to go with this guy about right there, this blue one. And then I'm going to go with this green one right here from A to the opposite perpendicular, so somewhere about right there. I might be a little off, but that's pretty close. So basically, I want to find an equation for this blue line in slope-intercept form, and I want to find an equation for this green line in slope-intercept form, and set up my system of equations so I can find that point of intersection. Oh boy, it's going to take some work because I'm not giving a lot of information. I just know points, don't I? Well, we need slopes and we need y-intercepts. So let's think about this. This first one, this blue one, I'm going to use point slope form to find my equation. Because it's a little quicker with point slope form. I know a lot of us aren't totally used to that. But I'm going to use point slope form. So do I know the slope of this blue line? I don't yet. But I know it's perpendicular to this line, isn't it? I know it's perpendicular to that line, and I could find the slope of AC. I could find the slope of AC, right? Just by counting, it goes up 1, right? 1, 2, 3, 4, 5, 6. Up 1, right? 6. So I know AC has a slope of 1/6. Well, the blue line has a slope that's the opposite reciprocal, right? So I know it's -6/1, or just -6. Because it's the opposite reciprocal. It's perpendicular. So I'm going to use -6. Well, do I know a point that's on that blue line? Sure, this vertice at B, don't I? So I can plug in -3, -3. So y minus -3. And over here times x minus -3. Well, minus and negative is really adding a positive, so I'm going to change both those around. So it's really +3. And to get it in slope-intercept form, all I got to do is simplify. So I distribute first, and I get -6x minus 18, and then subtract my 3 over. So I got y equals -6x minus 21. So there's my first equation. I know that this blue guy is y equals -6x minus 21. Now I got to find the equation for the green line, because I want their intersection. Well, this one I'm going to use slope-intercept form. Y equals mx plus b. I'll show you the difference between the two. I can use either one, point slope or slope-intercept. Well, I don't know its slope yet, but I could find it. Well, I got to look at this guy right here, this BC, because it's perpendicular to that one, isn't it? So if I know the slope of BC, the m of BC, the slope of BC, I know it's the opposite reciprocal for the green. So it looks like I'm going 1, 2, 3, 4 down, and 2 to the right. So 4 down, 2 to the right, which gives me a -2. So rise over run, which means my perpendicular slope is the opposite reciprocal of that. That's really -2/1. So opposite reciprocal gives me a +1/2. So I know it's a +1/2. And I know a point that's on that green line at A here. So 1, 2. So I got to plug in 1, 2 into my slope-intercept form. So 2 equals 1/2 times 1 plus B, which is 2 equals 1/2 plus B. Subtract my 1/2 from both sides. So B equals 1.5 or 1.5. So B equals, I'll just put 1.5. That's okay. So my equation for the green one is y equals, we said 1/2 for the slope, x plus 1.5. I'm going to go write that up here. Y equals 1/2 x plus 1.5. So there's my two equations. I did the first one, this blue one, using point slope. Okay, I thought that was a little bit quicker. And then I got my second one using slope-intercept form. But in the end, I write them both in slope-intercept. That's the key. So now I have my two equations. I have my blue one, y equals -6x minus 21. And I have my green one, y equals 1/2 x plus 1.5. Now I have a system, right? Two equations with two variables. So I'm going to do substitution. I'm going to plug this in for y. So now I basically just set these two equals. So -6x minus 21 equals 1/2 x plus, I'm going to change this back to a fraction. I get worried if I do too many decimals, sometimes I end up rounding and I'm not very exact. So I'm going to say 1 and 1/2. So now let's get our x to one side. So I add 6x, and we subtract 1.5 from each side. Subtract 1.5 from each side. So that's gone. We're left with negative 22.5 equals 6.5x, and that's gone. And remember, we talked about how to type this into our calculator, so we don't have to worry about changing to improper and all those things. So negative 22.5 divided by 6.5. I'm dividing by 6.5 on both sides. So that means x is going to be negative 3 6/13. So there's my x coordinate. So far I know I'm going at negative 3 6/13. There's part of my orthocenter. And to get the other part, I got to plug this back into one of my equations. So I'm going to go ahead and plug this all the way in up top here in for x. So I got y equals negative 6 times negative 3 6/13 minus 21. And so I got to take negative 6 times negative 3 6/13 and subtract 21. And y gives me negative 3/13. So go ahead and use your calculator, save yourself some time there. Negative 3/13. So there we go. There's my exact orthocenter of this triangle. Whew, that took a little bit of work. Okay, but use the things that you know, right? To find intersecting lines, I need a system of equations. You know how to find equations of lines in slope-intercept form. It just takes a little bit of thinking. Okay, so bear with me. All right, good luck to you.